Optimus just took a giant leap forward, and this time, it's not just about smarter software or stronger hardware. Elon Musk just dropped a bombshell in Neuralink's 2025 summer update that connects two of his most ambitious projects, Neuralink and Tesla Optimus, in a way that feels straight out of science fiction. But it's real. Right now. Here's the core of it. Anyone with a Neuralink chip can now control a Tesla Optimus robot using only their mind. Let that sink in. This is no longer a theoretical possibility. It's happening. And the implications? They're enormous, not just for robotics or neuroscience, but for what it means to be human in a machine-powered world. Welcome back, guys. Alfie here, bringing you another groundbreaking development. Neuralink has just enabled real-time control of Tesla's Optimus robot using the human brain. You're watching the AI Nexus, and as always, we're here to bring you every step of the future. Let's go. So let's break this down. In this year's Neuralink update, we met Alex, a patient who suffered a spinal cord injury. Before Neuralink, he couldn't write, couldn't draw. That part of his life was just gone. But now, with a Neuralink chip in his brain and a robotic arm linked to that chip, he can write again. He can play rock, paper, scissors using a robotic hand displayed on a screen. Each finger controlled in real time, directly from his thoughts. And here's where it gets wild. This robotic hand he's controlling? It's not just some medical tool. It's a prototype from the Tesla Optimus robot. The same humanoid robot Elon Musk wants to mass produce and roll out into homes, factories, and offices around the world. Alex, through Neuralink, is directly controlling Optimus hardware. We've just crossed the threshold where a human brain and a humanoid robot can operate as one. The barrier between biology and machine is getting thinner, fast. Now Musk isn't stopping there. He says the vision is full body control. You could think of moving an arm, and Optimus moves it. Think of walking, and Optimus walks. Want to cook dinner, clean the living room, carry heavy tools? With Optimus, you could perform any of those tasks, just by thinking them. This is physical telepresence, and this isn't just some vague roadmap. Neuralink has already shown the proof of concept with Alex's robotic hand. The next step? Full-body Optimus integration. We're not talking about replacing humans with robots. We're talking about empowering people, especially those who've lost physical capabilities, with robotic extensions they control as naturally as breathing. This changes everything for people with disabilities. Imagine a person who's paralyzed, who hasn't walked in years, suddenly gaining the ability to move again, not because we've restored their limbs, but because we've given them a robotic body controlled by their mind. This isn't science fiction anymore. Let's talk about the science behind this, because it's nothing short of mind-blowing. Neuralink's chip reads electrical signals from the brain, specifically from the neurons that fire when you think about moving. Those signals are decoded in real time, then translated into motor commands that drive robotic hardware. This is more than just pressing buttons or using eye-tracking systems. It's the brain communicating directly with the machine. In Alex's case, when he thinks about curling a finger or drawing a letter, his brain sends out patterns of activity that Neuralink decodes. The decoded signal is then used to control the robotic fingers or pen. There's no delay. It's fluid. It's intuitive. But Optimus adds a whole new dimension. It's not just a hand. It's a full humanoid robot capable of walking, grasping, balancing, and lifting. When you combine Neuralink's decoding with Optimus's physical capabilities, you get something truly transformative. A human mind with a mechanical body that never tires, never weakens, and never forgets. Now think about what this means for elderly individuals. As people age, mobility becomes a daily struggle. Lifting objects, climbing stairs, or even just opening a jar can become exhausting or impossible. But what if they had access to Optimus? Not just a robot that works for them, but a robot that becomes an extension of them. A robotic arm that helps pour tea without spilling it. Legs that help them climb stairs by proxy. Hands that help tie shoelaces, hold grandchildren, even paint a canvas again, all by thought. It's not about replacing the human body. It's about enhancing it where biology starts to fall short. This is the promise of Neuralink plus Optimus. And here's something Elon Musk hinted at, which could be the biggest breakthrough of all. Neuralink isn't just about controlling robots. It's also about healing. Musk believes that one day, Neuralink could reconnect damaged pathways in the spinal cord, essentially reactivating the brain's natural communication with the body. If successful, this would mean that people with paralysis might not even need a robotic body. They could regain full use of their own. But while that's still in development, the Optimus interface offers a bridge. A person who can't walk could send movement commands from their brain to an Optimus unit, one in their home, their office, even across the world. This means you could be present somewhere, physically, without actually being there. You could attend a concert, give a keynote, or dance with your partner, through a robot by thought alone. It's like teleportation, but real. And the potential doesn't stop with individuals. Imagine teams of humans controlling fleets of Optimus robots in factories, warehouses, or construction sites, all through thought. No need for bulky exoskeletons or complex controls. Just one person, linked to one robot, or many. Hospitals could have expert surgeons control Optimus units remotely for emergency procedures in remote areas. Disaster zones could be navigated by robots with human brains behind them, able to make real-time decisions using the human mind's unmatched adaptability. Suddenly, geography doesn't matter. Physical limitations don't matter. You just think, and Optimus acts. That's power. That's freedom. Now, let's bring this back to reality. How far are we from this future? Well, we're already seeing the first steps. Neuralink's real-time brain decoding is no longer a lab demo. It's working in human patients. The robotic hand is functional. The next logical leap is integrating that control into full-body Optimus robots. And here's where Tesla's advantage comes in. Tesla isn't just building Optimus in isolation. They're using their vast manufacturing infrastructure, gigafactories, automation systems, supply chains, to make Optimus scalable and affordable. And they're constantly updating it. With each new version, Optimus becomes faster, more agile, and more capable of mimicking human motion. The software side is advancing too. Tesla's Dojo AI training supercomputer and real-world video data collection are powering Optimus's ability to understand and navigate physical environments. So when Neuralink plugs into Optimus, it's not just giving Optimus a brain, it's giving a human brain access to one of the most advanced robotic bodies ever created. Let's also talk about how personal this could get. A user might customize their Optimus avatar: height, skin tone, voice, facial expressions. Your robotic proxy could reflect your identity, your personality, even your style. And since it's brain-controlled, every gesture, every pause, every glance is yours. You wouldn't just be piloting a machine, you'd be expressing yourself through it. Think of what that means for people who've been unable to express themselves for years. Suddenly, they have a body again, a voice, a presence. That's not just technological advancement, that's human dignity restored. There's also something quietly profound about the emotional layer here. Alex wasn't just playing a game or scribbling words, he was creating, expressing, connecting. With a machine hand, yes, but powered by his human will. That's what makes this update so powerful. Elon Musk and his teams at Neuralink and Tesla aren't just building tools, they're building bridges between humans and machines, between thought and action, between people and their lost abilities. And that's the real headline here. This isn't just Optimus with a brain. It's Optimus with your brain, your memories, your intentions, your creativity, all flowing through a robotic vessel that can carry them into the world. It's a new definition of what it means to be alive, to be present, to act. Now, will this be widely available tomorrow? No. There are still big hurdles. Regulatory, ethical, medical. Neuralink's brain interface must go through years of testing to prove it's safe and effective at scale. The Optimus robot must become more robust and affordable to enter millions of homes. And there's the challenge of merging these systems in ways that feel natural, intuitive, and reliable for all users. But the path forward is now visible. The foundation is laid. We've seen the demos. We've seen the connection. The human brain can talk to Optimus, and Optimus listens. In a way, we're witnessing the birth of a new kind of intelligence, embodied intelligence. Not just artificial intelligence acting on its own, but human consciousness expanding through physical machines. And it raises a profound question. If your mind can live beyond your body, where does you end and the machine begin? That question might take decades to fully answer. But today, we're not debating philosophy. We're watching Alex write. We're watching Optimus move. And we're seeing the walls come down between mind and machine. Elon Musk just made one thing very clear. The future isn't about replacing humans with robots. It's about giving humans more ways to be human. But while Elon Musk and Neuralink are blurring the line between mind and machine, over in China, an entirely different kind of robotics race is unfolding. One that's shaking up the entire global balance of AI power. 3 massive breakthroughs just shook the AI and robotics world, and when you connect them, one message becomes crystal clear. China is aggressively positioning itself to dominate the future of intelligent machines. From stadium-sized humanoids to micro-scale surveillance bots. Welcome back, friends. Alfie here with 3 massive updates that show just how fast China is moving in the AI and robotics space. You're watching the AI Nexus, and as always, we're here to bring you every step of the future. Let's go. Let's start right where the spotlight is hottest. On the field. But not your usual football field. We're talking about Robo League, the World Robot Soccer Finals, happening this Saturday in Beijing. Now, if you're picturing boxy bots waddling around and kicking a ball, think again. These are fully autonomous humanoid robots, walking, running, balancing, dribbling, passing, and even defending without a single remote control in sight. It's not just robot soccer. It's a full-scale display of real-time AI decision-making fused with dynamic motor skills. This isn't a demo. It's a battle arena for the next generation of general-purpose humanoid AI. And for China, it's a public declaration. We're not experimenting with robotics. We're building a future where machines think, move, and win like humans. Let's break this down. The Robo League humanoids aren't just remote-controlled shells. Each bot operates entirely autonomously using onboard perception, planning, and control systems. Imagine this. A robot sees an incoming ball, predicts its trajectory in milliseconds, chooses the best action, executes a full-body motion plan, and kicks, all in real time. That's not just robotics. That's embodied AI at a world-class level. And it's not just 1 or 2 bots out there showing off. Dozens of Chinese universities, startups, and military-affiliated research centers are participating. The top contenders? Teams from Tsinghua University, Zhejiang University, and China's National Intelligent Robotics Center. This event is more than a competition. It's a field test for China's humanoid platforms, some of which will likely evolve into the same machines used in factories, homes, military outposts, and space missions. And the crazy part? These bots are getting better with each tournament. Just 2 years ago, many of them could barely stay upright. Today, they're executing multi-bot passing plays, adapting to opponents, and playing for 90-minute matches without overheating. Why does this matter? Because robot soccer isn't just fun and games. It's a benchmark for generalizable AI. To succeed, these bots need vision systems that can operate in dynamic lighting conditions, balance control to run on grass-like turf, and intelligent decision-making to coordinate with teammates and outsmart opponents. In other words, this is a sandbox for general intelligence in physical form. And China's not just participating, they're leading the scoreboard. While humanoid robots on the football field are capturing headlines, another development is sending chills down the spines of intelligence agencies worldwide. China just revealed a mosquito-sized robot drone. That's right. A fully functional aerial drone measuring just 0.6 centimeters. To put that in perspective, that's smaller than a grain of rice. This isn't science fiction. This is real, and it's working. The drone is bio-inspired, modeled after the structure and wing movement of an actual mosquito. It can hover, navigate through tight spaces, and potentially even land undetected. Imagine swarms of these silently entering a building, capturing video, relaying audio, mapping environments, or even interfering with electronic signals. Now imagine it's already happening. The implications for espionage, urban warfare, and domestic surveillance are immense. From a technology standpoint, building something like this is incredibly difficult. We're talking micro actuators, sub-millimeter power supplies, nanoscale communication chips, and incredibly lightweight materials. Yet somehow, Chinese researchers have pulled it off. And more than that, they're preparing to mass produce it. Micro drones like these aren't just cool gadgets. They represent a new generation of distributed AI systems. Tiny autonomous agents that can work together like a swarm, adapt to new conditions, and complete missions that traditional robotics simply can't handle. It's a massive leap forward in robotics miniaturization, and a chilling glimpse into where China's military R&D is heading. So we've seen China's advances on the sports field and in the spy skies. But what's happening behind the scenes might be the biggest move of all. According to the latest global patent data, China now leads the world in humanoid robot intellectual property filings. That includes locomotion systems, AI learning architectures, joint designs, skin materials, balance control, and vision processing stacks. Let that sink in. In terms of raw patent numbers, China is outpacing traditional robotics leaders like the US, Japan, and South Korea. And we're not talking about a few lucky filings. This is a full-scale IP land grab, an aggressive effort to own the foundations of the coming humanoid robot era. Why is this so important? Because in the next few years, every country, every tech company, and every factory is going to want humanoid robots. They'll be used for logistics, caregiving, defense, entertainment, search and rescue, you name it. And the companies who hold the key patents? They'll decide who gets to build, license, or distribute the core technologies. China's strategy is simple but powerful. Dominate the standards, control the future. They're not just building robots. They're building the legal and technological frameworks to ensure everyone else builds their robots too. If these breakthroughs were isolated, it might be easier to dismiss them as one-off accomplishments. But that's not the case. What we're witnessing is a coordinated national effort that spans government, academia, military, and private sectors. Chinese state media is now heavily promoting robotics as the next national pillar industry. Billions in funding are pouring into AI robotics startups. Universities are receiving state-level directives to focus their engineering and AI programs on physical automation. Even China's military budget now includes major line items for humanoid development, micro-drone swarms, and embodied intelligence. There's a reason the US Department of Defense has launched a new AI and robotics countermeasures task force. It's not just about catching up. It's about trying to stop what looks increasingly like a runaway train. We're no longer in a world where Boston Dynamics and Tesla have a clear lead. The landscape is shifting fast, and China is now shaping the terrain. So what does this all mean? When humanoid robots can outplay humans in soccer, micro-drones can slip through your vents, and a single country holds the lion's share of IP for robotic bodies and brains. That's not just a shift in tech. That's a geopolitical power move, because whoever leads in robotics won't just dominate factories or surveillance. They'll dominate the economy. They'll redefine what military superiority means. And they'll set the global ethical and regulatory norms for how autonomous machines operate in our world. China knows this, and they're moving. Robot soccer is just the beginning. It shows us how advanced Chinese embodied AI has become. The Mosquito drone is the warning shot, proof of how far they're willing to go to develop systems that are stealthy, powerful, and fully autonomous. And the patent race? That's the long game. It's the legal lock China is placing on the global robot revolution. It's all part of the same story. A story where China doesn't just want to compete. It wants to lead, shape, and control the future of robotics. And the rest of the world? It's scrambling to respond. Let's take it from the abstract to the personal. Why does any of this matter to you? Because this isn't something happening in a lab on the other side of the planet. It's the beginning of a transformation that will touch every part of your life. In a few years, the robots stocking your grocery store shelves, cleaning hotel rooms, or monitoring power grids may not be made in America, or even Europe. They may be Chinese-built, Chinese-coded, and Chinese-patented. And in global conflicts, don't be surprised if Chinese drone swarms play a leading role, not just as weapons, but as scouts, saboteurs, and sensors. And if your country wants to build its own robots, They may have to license key technologies from Chinese firms or comply with standards set by Chinese regulators. This is what technological power looks like in the age of AI. It's not just about who builds the best robot. It's about who sets the rules for everyone else. So, China's robots are ahead in the global IP race for humanoid systems, positioning themselves to gatekeep the most transformative tech of the 21st century.